Welcome back to College Algebra, MAT 150. In this lecture, we will be going over special cases when solving linear equations. And not just linear equations, as it turns out, it will actually apply to a lot of other equations as well. So, two types of special cases can arise when solving equations. Sometimes we can have no solutions, and sometimes we can have all real numbers being solutions. So infinitely many, as it turns out, basically can be all of our solutions. Normally, we just get x equals a number, and then we're done. But these other two cases come at a special time. So when we're normally solving, we get x equals a number, but if we get something false when solving, so basically the variable completely goes away, and we're left with something like 0 equals 2, 3 equals -1, etc., then that's something that's completely false, and it turns out that means that we have no solutions. No matter what we plug in, for x, we would never get something that's a true statement out. It's always false. On the other hand, if we get something that's always true, like 0 equals 0, 5 equals 5, etc., then that means we have all real numbers as solutions. So, for number one, we have negative 24x plus 7 equals 17 minus 24x. So we're going to solve like we did for the linear equations. I want to try to get all terms with x to one side. I'm going to start that process. And however, if we kind of quickly notice this, I'm adding 24x to both sides, and that cancels with the negative 24x here, but it also cancels with the negative 24x there. And then we're left with the statement, if we do nothing else, 7 equals 17. Well, is that true? Of course it's not. 7 should never equal 17 in base 10, but that's a whole nother can of worms. This is a false statement. 7 equals 17 is not true. So we say that this equation has no solutions. And that is our answer. So what about the next one? 3 minus 7x equals negative 7x plus 3. Well, we start the same way. Again, I'm trying to get x's to one side, so I'm going to add 7x to both sides to get this over here. But when we do this, we do the same thing to both sides. It cancels here and it cancels here. And here we're left with something like 3 equals 3. Well, over here that was something that's not true, but this is always true. So for this linear equation, we say that all real numbers are solutions. This is a perfectly fine answer. Another way to represent all real numbers, just the term all real numbers, is an R with an extra line, an extra vertical line. And sometimes that would be perfectly representative of all real solutions. That concludes this lecture.